Hello everybody, welcome to the shop. So today we are taking on the Green Machine project. I've got a used Green Machine. Bought this puppy on the Facebook Marketplace for 15 whole dollars. Um, you may see there a Makita drill. Or if I hold the camera where you can see it, you may see it. Yeah, I've got a Makita drill. The chuck is completely seized up in that. So what I'm planning on doing is taking the motor and taking the gearbox out of that, printing a motor mount, mounting it to the frame of the Green Machine, printing some sort of sprocket or pulley or whatever you'd call it, and doing a belt drive system. I've been wanting to motorize some sort of vehicle, whatever, for my daughter for quite a while. I've been thinking about scooters, tricycles, Green Machine, obviously. Once that came into mind, I realized that is the way to go. There's a lot of different reasons for that. One of the primary reasons being the way this works. I don't know if you call it a clutch or a one-way bearing or what, but the pedal on this works like a bicycle. You pedal forward, it drives it. You pedal backwards, nothing. So it doesn't matter how fast that electric motor ramps up and gets that wheel spinning, it's not going to overpower and break my 7-year-old daughter. And that's a good thing because I do not want to break my daughter. It's got the traditional, Green Machine stuff. Steers by using these handles here. It throws out the rear end on it and causes it to swing wide and turn the direction you want to go. It's got the brake right here. So what I want to do is put a similar type handle on this one and have that controlled throttle. Probably run some sort of mechanical linkage to that actual switch, have it mounted somewhere, have that linkage operate some sort of lever essentially and depress the switch so that you've got a variable throttle just like the drill has. So pull the gearbox and the motor out of there, get the dimensions on that, get dimensions on the frame, design something in Fusion 360, get it printed out. I don't know if the gear reduction of the existing gearbox is going to be enough for what I want to do here. Basically, any motor that's going to come in a handheld drill or an angle grinder or anything like that, they're electrical motors, they, without any sort of reduction, they rev to incredibly high RPMs, like 15, 20, 30,000 RPMs. Depends if they're brushed or brushless. This one is a brushed motor, so probably not quite as high. I don't know if that's actually how that works. But anyhow, I don't know if this is going to be enough reduction. Basically, it's basic physics, mechanics. Whenever you reduce the speed through a gearbox or any sort of transmission or anything like that, it's going to increase the torque by whatever factor that the speed is decreased, minus any loss for things like friction, heat, etc. So I'm going to put the sprocket or pulley or whatever you want to call it on the front end. It's going to go right here on this part. Run a belt back here to the motor that'll be mounted somewhere around there, and I can increase or decrease the size of this to adjust that gear ratio from its base reduction going through that gearbox. So I just have to experiment with that, see what works. I have a couple options. Well, actually, all I have right now is PLA. That's the type of plastic filament for a 3D printer that's most common. It is very easy to work with. It's very strong, but it's quite brittle and it's not very temperature resistant. So if we're just holding down a motor right here, and all it has to do is hold against the torque of trying to turn this thing, I think it'll handle that just fine. But now when it comes to this over here, where we're going to have a plastic disc that's going to have a belt going around it, and that belt's going to be under torque and under tension and spinning, that's going to generate heat. That PLA in that circumstance is just going to turn to goo. Not going to do a very good job of anything at that point. So what I'm thinking is using a type of filament that's called PCTPE. It's kind of the best of all worlds. It's not terribly difficult to work with. It is a blend of nylon and TPE. TPE stands for thermoplastic elastomer. It's kind of grossly misunderstood in the 3D printing world. TPE just represents an entire category of plastics that are temperature resistant, and there's other properties that apply to them, but I don't know because I'm not all that smart. But this one is fairly inexpensive. I plan on having access to some of it fairly soon, so I think I'm going to just try it out, see if it works. But that's the general game plan. Really, all there is to do at this point is to just dive in, start tearing stuff apart, and see what we've got. I've never done anything like this before. It may sound like I know a little bit about some of this stuff. I really don't. I've got this workshop and I've collected a pretty decent variety of stuff, but all I've ever done is build a cabinet for my 3D printer, and I tinkered with electronics a lot whenever I was a kid. So this is going to be a crash course in all of this for me, but I look forward to it. It's going to be a good learning experience, and I really look forward to being able to make something really cool out of this thing for my daughter. And worst case scenario, just take all of it off and then she's got a green machine. So, yeah. All right, well, I guess it's time to dive in, so let's learn some stuff. So with just a few minutes work, we are here. We've got everything disassembled to the point where I can go ahead and get the frame measured. Next up, I'm going to need to pull apart that drill, get the motor and the whole gearbox, everything in there measured, take those measurements and then put them into Fusion and start working on some sort of motor mount to get that all held down, figure out what I want to do with the trigger as well and the throttle. Definitely need to dig into that fellow over there, get a look at the innards, see what it's made of, see the components. That actually is probably what I should do next, because everything that follows that will probably be dependent upon what I find in there and you know, what I learn, you know, how I'm going to have to actually mount the sprocket, what is moving freely in there, you know, if all of that component is inside of the axle more or less, or if there's some sort of larger assembly that allows the pedal to spin freely. Just need to investigate, see what I can learn, and then take that info and move forward. Okay, so that's going to wrap up this one. Thanks for joining me. I hope you were at least somewhat entertained, maybe learned a little bit of something. I know I learned a few new things just tinkering around with all this stuff. That's kind of the point of all this, is the fact that in the process, I mean, you learn things everywhere. Everything you do, everything in life, you always learn something. If you acknowledge the fact that you learned something, it goes so much further. It does so much more to benefit you. So, you know, at some point I want to get to a spot where, you know, at the end of a video, I can essentially do an analysis. You know, what did we learn in this video? What did I learn in this video? I mean, you can do your own thing, but just taking the time and the effort to go back over it and account for what new information you have gathered, that can be enough to really permeate that information, to set that information into your brain. Whereas a lot of times it's kind of in one ear out the other, at least it is for me. So yeah, I guess that's it, and we'll see you next time.